morning, everyone. It is Monday, March 7th, and we are in the midst of a snowstorm, which is as complex as usual. Now, let me explain to you what's going on over here in the Chicago area. Probably as we speak, we had snow that overspread the area earlier today. That snow, according to the streetlight view, has turned into drizzle or freezing drizzle. And the question is why? Now, this was in the forecast. Now, usually you would think, why? It's because there must be warm air above the cold air. So the snow melts into droplets and then it freezes, but it doesn't have enough time to freeze before hitting the ground. If it had enough time to freeze before hitting the ground, that would be called sleet. But it doesn't have enough time to freeze before hitting the ground, so we call it freezing rain. Okay, that's a nice theory. That's what it says in all of the science books in elementary school. The only problem with that theory is that it's not correct. That might be true by freezing rain, but in the situation today, we have freezing drizzle, and that's not the reason why we have freezing drizzle. This is a different type of a freezing drizzle. The freezing drizzle we have today, this is going to be a big chiddush to many of you. A big chiddush, it's a big chiddush, is because of the following. So rain freezes when it's 32 degrees. So in all of the textbooks and everything, it always says that the precipitation that forms in the upper atmosphere, if it's below 32 degrees, the precipitation is going to form as snow. Okay? But the truth of the matter is that's not correct. It actually has to be 18 degrees. It has to be 18 degrees, before the precipitation could form as snow. Because it goes like this, it needs ice nuclei. You need to have some type of particle, or in this case, some type of ice particle. The initiation process. The ice has to be 18 degrees Fahrenheit. Once you have that, so then all of these other particles could freeze and stick onto it to create a snowflake. But if you don't have that little part, that ice nuclei, we're going to have to look up the terminologies. You can look it up to get a better idea, or maybe we'll have more on this at a later podcast. Then you do not get a snowflake. So, how do you get a snowflake? Why was it snowing? And why did it stop snowing? This is what happened. When the snow clouds went deep, tall into the atmosphere, so then the top part of the clouds, there was precipitation forming in the top part of the clouds. There's also precipitation that potentially could have been forming on the bottom part of the cloud. The clouds were saturated. The clouds are saturated. That's one major variable needed to produce precipitation. It's not the only variable. You need some other variables as well, but that was a major variable. So we had snowflakes. When you have the top cloud saturated, so the higher up you go, the colder the temperatures are. Temperatures actually drop 5.5 degrees every 1,000 feet you go up. So the temperatures actually were below 18 degrees. Not only that, they were even colder than that. Significantly colder than that. Some say it also has to be significantly colder than that. 18 degrees also, it's not a guarantee. Sometimes it really does have to be colder than that. Sometimes even at 18, we fail to get snow. So, snow was falling, and that was that. Then a dry slot moved into the area. A dry slot is associated a lot of times with a warm nose. Somehow associated, it's part of every storm system. The dry slot was forecast to move over the Chicago area. Any place that got this dry slot. Now, you would think if you got a dry slot in the upper atmosphere, that means it's going to be dry down here on the surface. Well, that could be. But in this case, it could also be that it won't be. Because all the dry slot did is it caused the top cloud to dissipate. But we still have the bottom cloud. And the bottom cloud is still saturated. So there's still a pretty good chance that precipitation is going to form in the bottom cloud as well. The only thing is that the bottom cloud is lower down, so the air temperature is above 18 degrees. And if the air temperature is above 18 degrees, we cannot get any snowflakes. So it goes like this. If the snowflakes were already falling from the upper part of the cloud, so then when it falls through the bottom part of the cloud, that water, the water vapor and the water droplets, the ice particles, they freeze on to that snowflake, making the snowflake larger. We never would have gotten a mixture of rain and snow in such a scenario. But now that the snow has stopped falling, all we have is the bottom part of the cloud. So now we have what's called supercooled water droplets. Supercooled water droplets are water droplets that are well below 32 degrees. Temperatures are probably in the low 20s. But in order for water to freeze, there also has to be some type of some mushes in the middle. It could be a tiny dust particle. It could be anything, but it has to be there. And if it's not there, the water will remain water. According to the National Weather Service, this remains true all the way to 37 degrees below zero, but it has been seen in labs before that the water remains water all the way up to 42 degrees below zero. So we have super cooled water. All it has to do is come in contact with something and it will freeze instantly. That's freezing drizzle. This is the difference between freezing drizzle and freezing rain. It's a very significant difference to me. To me, it's a very significant difference. Freezing rain is the classic thing everybody learns about in school. You have in that all those pictures, the diagrams, the snow falls from the sky. It falls into a warm layer. It melts, then it falls into a shallow cold layer. And then it freezes. Either it freezes before reaching the surface, in which case it's called sleet, or it freezes after reaching the surface, in which case it's called freezing rain. Now the question is, does that freezing rain freeze on contact? So sometimes it does. Now, the reason why it does is because of a process called evaporative cooling. So it actually could be that the water temperature is actually below 32 by the time it reaches the ground. So even in that process, it's possible for the precipitation to freeze on contact. In fact, you could have freezing precipitation even when the temperature is 34 because of evaporative cooling. That's especially true if we're in a dry air mass. If we're in a dry air mass, a lot of times the precipitation evaporates before reaching the ground, or at least it shrinks. But in any case, in general, freezing drizzle, I think, is a more significant event. I think, and the ice storms that I've been in have been situations with the weather conditions where freezing mist, Baltimore gets them a lot. The freezing mist ice storms turned out to be an inch, even more than an inch of solid ice. Very, very major stuff. So that's one of the things we have going on right now, is this complicated freezing drizzle, which makes snowfall so difficult to forecast. The other thing going on right now that's important to mention is that ice is slippery. Okay? What temperature does ice reach its slipperiest? So some say it's 20 degrees, some say it's 19 degrees. Once it's under 19 degrees, the ice takes on a form where it loses its slipperiness. At least it's not as slippery. And I wonder if there's a connection between the ice particles in the sky, which we said was 18 degrees, in order for the initial freezing, in order to produce the initial icicle, it has to be 18 degrees, and then after that we could have a snowflake. And this snowflake will get larger and larger. The more water vapor gets added onto it, the more moisture that gets added onto it, provided the temperatures are under 32. But the initial stage has to be 18. Sometimes it even has to be less. So is there a connection between that? Is there something that happens to ice at that temperature? There's a certain level of frozenness or something, and maybe that's also manifests itself in the fact that ice is not as slippery. Once the temperature is below 19 degrees, at 19 degrees, it reaches its slipperiest. It's also possible the article was not worded exactly. It could be that it's saying that under 19, the ice isn't really so slippery. not that at 19 it reaches its slipperiest point. Maybe really it's slippery 19 and up, and it's not slippery under 19. I don't know. That's something that has to be looked into, because ultimately the slipperiest ice, I would think, is the ice which has rain on top. But there are those that say that all ice has a thin glazed layer of liquid on top. That's something which would have to be discussed at a later time. Okay, everyone. The next topic that is very deserving of being discussed is this Thursday night, Friday night snowstorm. We have a low pressure system. We have a lot of stuff coming together, and the National Weather Service forecast discussion has spent an unusually large amount of time discussing this in their forecast discussion, because there is potential with this one. How could there not? How the amount of energy in the environment today is just mind-boggling. In March, I'm talking about March, this is March, but the polar night, there are areas where the polar night, it's still night. So you have the polar freezer is still on, but you have the hot sun from the south. It's mamish coming up at full force. We see it. We already spoke about how temperatures went into the low hundreds a couple of weeks ago in Texas, and we're seeing more and more of those 80s and 90s with dew points. Some of the charts showed dew points in the mid-70s yesterday. I couldn't find any city which had dew points in the mid-70s, but when you look at the map, it shows a shaded area of 70s. I don't know why it shows that, because I can't find any city which actually had those dew points, but I didn't look into Florida. Florida doesn't count. I'm speaking about Texas. Florida has warm water all year round, so it's significant in Florida too, but it's more significant in Texas. If we can get the dew points into the solid dew points into the mid-70s in Texas, that's a more symbolic, and it's both a simon and a siba that we're headed in the right direction. But dew points is a form of energy. It's not just temperature that's a form of energy. Dew point as well as a form of energy. And the main thing we're looking at in a snowstorm is not moisture. Maybe other meteorologists disagree, but from the research I did, it's the low pressure. It's the low pressure. You could have tons of moisture, the snow just doesn't fall. You could have an Alberta Clipper, a moisture-starved system. It doesn't produce much, but the snow does fall. But this Friday, we're getting a combination of the two. You can look on the weather map in the European computer model, and you see for the first time this winter, perhaps, to me, you see a solid low pressure system develop. It's clear on the map that it's strengthening, and it's something that the East Coast has been getting all along, but the Midwest, we've gotten plenty of snow. But to actually see the source being a solid low pressure system, not relatively low pressure, which, maybe it doesn't really matter, but to actually see an intensifying storm of 29.4, starting off at 29.6, and then intensifying to 29.4, and then 29.2, and 29.2 is the criteria for a foot of snow at the bullseye. On the lower end, I think that's a 12 to 18-inch bullseye when it's 29.2 for the East Coast. That's when it's mixed with the Atlantic Ocean waters. Exactly what's going to be happening here is something that people should stay tuned to, because we have other computer models taking the low pressure up the coast. In most likelihood, we're going to see 2 areas of low pressure, perhaps 3, but the one on Friday into Shabbos will have one going through the Midwest, possibly a little bit too far south for the Chicago area. That's what it looks like to me, but we're still several days out, or at least a little bit too far south for Chicago to be getting the bullseye of it. Chicago might not be in the heaviest part. And then on the East Coast, we usually do get a secondary area of low pressure, which develops off the North Carolina coast, and that you can clearly see on the map. In fact, that one, according to the European computer model, is developing into mind-boggling intensity. We're talking about hurricane strength. It's not just going under the 29s. It goes to 28.7, 28.4, 27.9. This thing is mamish. It's a Genesis. That's the definite. It's gonna by the evening. By one of these evenings, It takes upon the characteristics of abomogenesis, something which drops 1 millibar per hour for 24 hours. Thank you for listening. I wish everybody a good day. Just summary here. In the Chicago area, we are under a winter weather advisory due to freezing rain. Areas north of Chicago are under a winter weather advisory due to snow. Total storm accumulations expected to be 1 to 4 inches. The next storm expected to hit here is Thursday, Friday, or Shabbos. Either one wave or 2 waves of low pressure. We're right now waiting actually for the second half of the storm, which will be coming in a couple hours from now, probably at 8 o'clock or so. For today, we will see a couple more inches of snow. A lot of it might melt though because of the warmer temperatures and the solar radiation in March from the high sun angle. But then we have one wave of low pressure coming in perhaps Thursday into Friday, but a more significant one Friday into Shabbos, which the Chicago area might miss. We have to stay tuned to that one because that one in particular could be really significant from what I saw based upon the low pressure, and low pressure is the main thing. Low pressure is the main thing that we're looking at.